have introduced the mole concept in the role mole worksheets, let's go deeper into how we connect the atomic mass to large scale mass and do more different problems, okay? Before we do that, let's talk about formula mass and person composition. The first problem asks you to calculate the formula mass of phosphorus tribromide. Therefore, let's do this immediately. So you have to know what's phosphorus tribromide. It's a covalent compound made of two nonmetal, formula PbR3. In order to calculate the formula mass of phosphorus tribromide, we will need to add 1 time, okay, so this compound here is made of 1 phosphorus atom and 3 bromine atoms. Okay, the 3 that you have here only applies to the bromine. Therefore, we're going to use the periodic table to combine the atomic mass of phosphorus and the atomic mass of bromine. We're going to have 1 time the atomic mass of P plus 3 times the atomic mass of Br. These information can be found on your periodic table. So we're going to have 1 time the atomic mass of P being 30.97 U. U stands for AMU. It's the same as the molar mass in gram per mole. Plus 3 times the atomic mass of Br, 79.90 U. When we add them together, we get 270.67 U. Again, this unit, which is the atomic mass unit, is the same as gram per mole. So you can easily replace U by gram per mole, which means that PbR3 has a molar mass of 270.67 gram per mole. 1 mole of PbR3 weighs 270.67 gram of PbR3. And we find again, okay, the relationship that we talked about in the previous worksheet. Then you're asked to calculate the percent by mass of bromine in phosphorus tribromide. The formula is given to you in the textbook. It's going to be the mass of the element that you're looking the percent by mass for over the total mass of the compound times 100%. So, in phosphorus tribromide, we mentioned that we have 3 bromine. Here, this is the mass of the element bromine because we have 3 of them. Be careful. Therefore, we have a total of 3 times 79.90 U. The mass of bromine in PbR3 is 239.70 U. In order to find the percent by mass of bromine in, okay, again, this number that you have here is the mass of the element bromine in PbR3, and we have 3 bromine, so we have to times the mass by 3. 3 times 79.90 U. So let's calculate the percent by mass now. The percent by mass of Br is going to be equal to 3 times the atomic mass of Br over the formula mass of PbR3 times 100. It's equal to 239.70 U over 270.67 U times 100. Plug this into your calculator and you get to 4 sig figs. And you get to 5 sig figs, 88.558%. Why sig figs wise? This number is 5 sig figs. This one is 5 figs, and this number is exact. 100 is exact, so I need 5 sig figs at the end. Notice that by convention, okay, all the atomic mass, molar masses will be reported to 2 decimal places. It's a convention to make everyone's lives easier, okay? The atomic masses are reported to 2 decimal places. So let's do more problems very similar to the worksheet we did before. Problem 1. Convert 5.31 grams of calcium to moles of calcium. We are given grams of calcium and we want to convert into mole of calcium. So what are we going to do? 5.31 gram of Ca is given. What I want is mole of Ca, and set up your conversion factor, cancel gram of Ca. My gram of Ca cancel, and I'm left with mole of Ca. This information here is called the molar mass of calcium that you will find on the periodic table. 1 mole of Ca is equal to 40.08 gram of Ca. Therefore, 1 mole of Ca, 40.08 gram here. Grab your calculator, and to 3 sig figs you will find 0.132 mole of Ca. Okay? Sig figs, 3 sig figs here, 4 here. My answer is given to 3 sig figs. Let's keep going with the next problem. Problem 4. 90.2 mole of lithium to be converted to gram of lithium. So we're given the 90.2 mole of lithium. The unit we want now will be at the top, gram of lithium, and we want to cancel the mole of lithium. Again, this is called the molar mass of lithium. Information can be found on the periodic table. 1 mole of lithium is equal to 6.94 gram of lithium. 1 mole of lithium, 6.94 gram of lithium. Notice that the mole cancel. I'm left with gram. Plug this into your calculator, and to 3 sig figs you get 626 gram of lithium. So we went from grams to mole, mole to grams by using the molar mass of the specific element as a conversion factor. Let's take a look at problem 5 now. We have to convert 1.85 10 to the 22nd atoms of copper into mole of copper. So the given is the number of atoms and we want to convert to mole. 1.85 times 10 to the 22nd atoms. Atoms of what? Copper. We want to cancel the atoms of copper and convert to mole of copper. Where do I find this information? Okay, well, this information here, this is the definition of the mole as a counting number. 1 mole of X is equal, per definition, to 6.02 times 10 to the 23rd X. In this case, our X is Cu, atoms of copper. So 1 mole of copper contains 6.02 times 10 to the 23rd atom of copper. Then atoms of copper cancel, the mole is left, and you plug this into your calculator and you will get to 3 sig figs. 0.0307 moles of Cu. Now be careful when you're going to type this on your calculator. It's okay you cannot overuse the parentheses, but remember that you want to place parentheses here at the bottom to be sure to divide by 6.02 times 10 to the 23rd. Okay? The next question is asking about molecules of water. Therefore, we want to know how many molecules of water are in 4.32 moles of water. We're given 4.32 mole of water, H2O. We want to cancel our mole of water and convert to molecules of H2O. Notice that before we were talking about the copper atoms and a mole of copper. Now a mole of water molecule and how many molecules. Therefore, this information is the same. It's the definition for the Avogadro number. 1 mole of water contains 6.02 times 10 to the 23rd H2O, but those this time are molecules. For every mole of H2O, I have 6.02 times 10 to the 23rd molecule. My mole cancel and I'm left with molecule of water. I'm going to plug this into my calculator. Into 3 sig figs, I get 2.60 times 10 to the 24 molecules of water. Again, we can do the sig figs for these 3 problems. 3 sig figs, 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 the leading 0 don't count. 3 sig figs, 3 sig figs, 3 sig figs. Let's move on to the back of the page. Problem 7. What are we asked here? How many atoms of iron are in 5.05 gram sample of iron? So we start with the given. 5.05 gram of iron. We want to cancel the gram of iron and convert into, atoms of iron. There's a trick here. In the chapter 7, the stoichiometric chapter, you cannot build any conversion factor that does not contain the golden unit of the chemist, which is the mole, okay? We don't know the mass in gram of 1 atom of iron. We don't have the direct relationship between these two. But the bridge unit, the golden unit, is actually the mole unit. So what I'm going to do, because I don't know the relationship between these two, I'm going to break this conversion factor and insert the golden unit. What is the golden unit? It's the mole. By dividing here and timing here by the mole of Fe, take a look at that. These two will cancel now. These will cancel, and I will be left with atom. And by breaking up with the golden unit for the chemist, the base unit, the mole of iron, here I made appear the molar mass per the periodic table is equal to 55.85 gram of Fe, and what I have here, it's the Avogadro number. 1 mole of Fe is 6.02 times 10 to the 3rd atoms of Fe. So we can now fill in the blank. 1, 55.85 here. 1, 6.02 times 10 to the 23rd here. Grab your calculator. Plug this into your calculator and you get to 3 sig figs. 5.45 times 10 to the 22nd atoms of Fe. 3 sig figs, 4 sig figs, 3 sig figs. My answer is given to 3 sig figs. And the trick here, the key, was to break the conversion into 2 by going back to the base unit. Remember, we did something very similar in the dimensional analysis. Next problem, What is the mass in gram of 5.0 to the 24 uranium atom? We are given 5.0 times 10 to the 24 atoms of uranium. We want gram of uranium and cancel the atoms of uranium. Again, notice that I don't see the golden unit, so I'm going to break this conversion factor, make the golden unit appear. Mole of U. This is Avogadro's number. 1 mole of U is 6.02 times 10 to the 23rd atoms of U. And this is the molar mass of uranium. Per the periodic table, 1 mole of uranium weighs 238.03 grams. Fill in your blank. 238.03 grams of U, and 1 mole of U contains 6.02 times 10 to the 23rd atom. Plug this into your calculator and you'll get to 2 sig figs this time. 2.0 times 10 to the 3rd gram of U. 2 sig figs, 3 sig figs, 5 sig figs. Answer to 2 sig figs. Problem 9 now. First of all, we have to find the molar mass of calcium chloride of Ca. So 1 time the molar mass of Ca plus 2 times the molar mass of Cl. This is going to be equal to 1 time 40.08 gram plus 2 times 35.45 gram. Therefore, the molar mass of calcium chloride is 110.98 grams. Of CaCl2, this is the mass in gram of 1 mole of CaCl2. Again, because this is now a formula mass, we have the ionic compound of calcium chloride. This is what we call the molar mass of calcium chloride. Now that we have this, we can solve the problem. It's asking us to find the mass in gram of 1.34 mole of calcium chloride. Given 1.34 mole of CaCl2 time, you cancel your mole of CaCl2 and you convert to gram of CaCl2. We're going to fill in the blanks. 1 mole of CaCl2, 110.98 grams. Convert moles of calcium chloride into grams of calcium chloride, and here we use the molar mass of calcium chloride to fill in the blanks. Okay? Because this is here the conversion factor that's going to allow us to cancel the mole of calcium chloride and to be left with a calcium chloride unit. We're going to plug this into our calculator and we'll get to 3 sig figs, 149 grams of calcium chloride. Sig figs wise, 3, 5, answer to 3 sig figs. The final problem asks you to find the gives you information as a bowl contains 45.3 grams of KNO3. You guys remember what's KNO3? KNO3 is potassium for the K plus ion and nitrates for NO3 minus, the polyatomic ion, so it's potassium nitrate. How many moles of KNO3 are in the bottle? And the bottle contains 45.3 grams of potassium nitrate. So we're given 45.3 grams of KNO3. We want to get moles of KNO3, therefore we have to cancel gram of KNO3. This conversion of KNO3 that we can calculate by using the periodic table. 1 time the molar mass of K plus 1 time the molar mass of N, and be careful, 3 times the molar mass of O. Therefore, 1 time 39.10 plus 1 time 14.01, 1 time again 39.10 gram plus 1 time 14.01 gram plus 3 time 16.00 gram. Therefore, the molar mass of potassium nitrate is 101.11 gram of KNO3, and this is equal to 1 mole of KNO3. Fill in your blank. Plug this into your calculator. Again, notice that your gram cancels and you're left with mole. Plug this into your calculator. Into 3 sig figs, you get 0.448 mole of potassium nitrate are in the bottle. 3 sig figs, 5 sig figs. Answer given to 3 sig figs.